Hello there, and thank you so much for choosing True Blue Solar Code to be your trusted service provider for your home energy system. In this video, I'm going to give you a live walkthrough of the Sungrow app, which is called iSolarCloud. We'll use someone else's site to describe it since your site was only just commissioned and there won't be enough data there until a few days pass after the installation. So let's jump straight into iSolarCloud and we'll give you a walkthrough of the dashboard. So this here is what it looks like on a computer screen, and what you see on your phone will be quite similar. I'm going to use the computer because this is the easiest way for me to film this video to describe it. So here we're in a site for a previous customer of ours, and basically we're in the overview tab here, and you can see we've essentially got these little icons. So we've got solar panels right now. As you can see, it's 9:14 p.m. So solar panels aren't producing any power, and Rod is drawing in 1.04 kilowatts from his battery to supply power to his house. So that there is basically like the live data that's happening on site currently, and generally, it's around about 30 seconds behind like actual time. Now, sometimes you'll see the battery in the daytime when there's lots of solar. It might be charging and it might be, say, for example, 95% full or 90% full, but some of the solar is getting pushed into the grid. Don't be alarmed by that. The battery, once it reaches a certain level of charge or a certain temperature, depending on the battery management protocol, it'll slow down the rate that the battery can charge at, just to like enhance the lifetime of that battery. So something I hear people are a little bit concerned about from time to time. So just thought I'd point that out. And also you might see sometimes that there looks like there's power coming in from the grid when the battery's full. But generally this is just a rounding error, or that it's just showing that the battery has reacted, 10 seconds after the load's turned on. So like, let's say, for example, you're using right now, like this house, 1 kilowatt of power, and then all of a sudden, you turn your oven on, which is a 32 amp circuit. And 32 amps is about 6.5, 7 kilowatts worth of power. So the battery is going to take, 10 to 30 seconds roughly to respond to that load and start outputting the right amount of power to match what you just turned on in the house. So you will see little rounding errors in this live data here. Don't be concerned, there's nothing wrong. The system is working the way it's designed to work. So this is the grid here. This is the grid. There's obviously nothing coming into the house from the grid because it's just got a stable base load being ran from the battery. And these little lines will flow as the power goes between the different parts of the circuit. So it shows you here your state of charge of your battery, and that is also reflected. Your state of charge of the battery is also reflected here on this line. So you can see on this green line, it's saying 89%. You can see it's a little bit slower than the live data. So this battery state of charge, you can see there the green dot on the pop-up there, the green line. On the right-hand side there, we've got the battery state of charge on the right-hand vertical axis. And then on the left-hand vertical axis, we've got power. And then on the horizontal axis of this graph, we have the time. So this is basically in the middle of the night, or 1 a.m. sort of thing here. 1 a.m. comes through to 7 a.m., comes through to 12 p.m., comes through to, say, 4 p.m., 6, 7 p.m., and then right now up to 9 p.m. And that graph will continue to show through till a full day, basically. Like I've just clicked back a day here, so you can click forwards and backwards through the days. You see a nice sunny day here, and you can see this bloke's installed a big battery. It's a shoulder period at the moment, October. We don't really flog the air conditioner that much. So his battery's quite full. There's been plenty of sun. You can see every day his battery's just fully topped up. This one was installed around September. It mustn't have been using much air conditioning back then either. So, did we have it in August? No. It'd be nice to show you some air conditioning days, but first day of install, and he's not using any air conditioning. Anyway, all right, let's go through the colors of the graph. So we got the kind of the key down here. We got orange for PV. We have purple for grid, blue for battery. Let's call it yellow for load, and green for the battery state of charge. So all of these four things are read from the left-hand vertical axis. The battery state of charge is the only thing that you will need to read from the right-hand side over here. So everything else in the graph goes off the left-hand vertical axis. So like, let's just pick a time here. So it's 4:15 in the morning. Obviously, there's not any PV because there's not any sun hitting the panels. We're not going to get any power out of the panels. The battery at that time is at 77%. So there's no power getting pulled in from the grid. As you can see, grid equals 0. And the battery equals 1473 watts, which matches the load. So the battery is matching the load in the house. And when I say load in the house, the load is whatever the power is being used in the house. So it might be the fridges and the Wi-Fi circuits and stuff like that, but whatever's left on overnight, not much. So then if we go to, say, this point here, when you've got the blue battery line below the graph here. So at 9:30 in the morning, the battery's starting to recharge again. So what's happening here is you've got your solar producing 6 kilowatts. Again, there's plenty of battery, there's plenty of solar, so the grid, we're not using it at all. But the leftover solar at the moment is going back into the battery. So that's why you see the battery being minus 5436 and the load being 565. Now, if you did the PV minus the battery, you'd get equals the load. And that's basically that point minus that point equals that point. And the battery state of charge is slowly climbing up to 100%. Once that battery state of charge gets close to 100%, the solar will start exporting so it doesn't overcharge the battery. And as you can see, there's like the purple line here on the grid starts to go into negative. So that means we're feeding power into the grid now. So we've filled the battery fully up. We started to feed power into the grid. And that's essentially almost everything you need to know there. A few more things you can change to a table display if you ever want to like look at this here. If you want to get some data out of the system, a lot of people, this is going to be way too detailed. You can download and export that data if you want to. We can use all of this stuff to build reviews, fault find on systems, R&D that we do here, so that when we're changing our design philosophy and stuff like that over time and refining it to make it better and better and better as we go, or just genuinely checking it to make sure it's still on point with best practices. For you guys, you've got these buttons up here. You've got days, weeks, months, year, lifetime, or custom periods. So you've got all these different options that you can view this data in. I recommend that you just use the chart because the chart's just so easy to read. All the same things again. So basically, this is a weekly display, a monthly display, yearly display. There's not much here because this one's only just being commissioned. But if we have a look in the week here for one day, so basically on the 14th of October, the PV produced 85 kilowatt hours. There was a tiny bit of electricity used from the grid, 0.1 kilowatt hours. That's probably just that tiny little bit due to the lack in response time for the battery to kick in. 60 kilowatt hours fed into the grid, a little bit put into the battery, a little bit discharged from the battery. And then the load just shows how much power did he actually use. It's a separate line item. So the load is like, well, how much power did he use for that day? 26 kilowatt hours. All of it comes from solar or battery, except for that tiny little 0.1 kilowatt hours that come in from the grid. And it's basically the same thing here. There's just a tiny little bit just dripping in each day. So yeah, that's that. Now, the rest of this stuff really is mainly for your installer so that they can do any fault finding and stuff like that. If you do want to connect to Amber's VPP or any other VPP, what you need to do is go into plant configuration, and you'll need to make sure you've got your NMI number in this section here. And you'll need to go down to this channel partner here and select your VPP operator, whichever one is the one that you want to sign up to. You will need to get specific instructions from your VPP operator for what they require. But in terms of getting